Hey guys, welcome to MetaCTF Live. This is no longer the pre-show banter, but the show itself. I'm Connor. I don't normally do these webcasts, but I've operated the booth sometimes. I'm a programmer for the BHIS side as well as the anti-siphon training side. And alongside me is Roman. He's MetaCTF. He's going to be going through some of his CTF challenges today. So really excited to see what we've got in store for the day. And yep, have at it, I guess, Roman.
Thanks, Connor. So, hey everyone. We're going to walk through some of the solutions from our August 2025 Flash CTF. So that's actually our, if you start counting back in January 2024, where we held our first kind of Flash CTF in the series, this was actually our 20th one. We had a few back in like 2021, 2022, but they're kind of sporadic. But you could say that this is our 20th Flash CTF. And I think we had close to 1,500 people sign up, so it was a really good turnout. But for those of you who are not familiar, every month, MetaCTF, with the support from Anti-Siphon and some of our other sponsors, we run a quick 2-hour mini CTF. We used to have 5 challenges per CTF just because it was a nice number. We realized that the audience in the Flash CTFs varies widely in terms of their skill levels. That's why we added a 6th challenge, just so we can have a little bit more room for easier challenges and a more gradual transition to the more difficult ones. So the most recent CTF had 6 challenges. It was 2 hours. And we actually had 3 winners that I can, well, I mean, we had a lot of people who cleared the scoreboard entirely. Maybe, can you see my, yeah, Juke, Mixit, and ETH007. Out of all the people that participated, we actually had 31 individuals clear the entire scoreboard, solve all the 6 challenges within the CTF. And let me see how long it took people to solve the first challenge. Let's see. The first correct solve was 36 seconds into the competition. That's pretty impressive.
Jeez. 36 seconds in, that is quick draw right there.
If you look at our practice environment, and I can share my screen. I don't know if you can see it, or if I need to reshare.
I think you might need to reshare.
Okay, let me try it. Yeah, and so if you look at our practice, so every month we're on the Flash CTF. Immediately, or usually 1 or 2 weeks after, we copy over all of the challenges from the Flash CTF into our practice environment. And you can sign up for that using this link, mctf.io/practice. The challenges are the same as from the Flash CTF. The only difference is that, for example, if a challenge goes down and we have to fix it, we usually only fix it in the practice environment. We don't update it in this environment. And after the Flash CTF closes, we disable the submission just so that the scoreboard stays locked. But in the practice CTF, you can actually go ahead and solve all these challenges. But one thing I was going to mention is we actually list who was the first person to solve it, who got the first blood on the challenge, and you can see how many seconds it took them to solve that challenge. Some of the harder ones, might not get solved at all during the competition, but some of the other ones, get solved pretty quickly. All right, well, so if you'd like to follow along, you can either join the practice environment or join the August Flash CTF. I'm going to paste both of the links in here just so you can take a look. Might need Megan to paste in the chat. But these are the 2 links so you can follow along. And all the solutions that I'm talking about, they're actually already published in our blog. So if you go to the landing page and you click on write-ups, this will send you to our blog, which has all the solutions already published and written out. And same goes for every single Flash CTF challenge that we've done in the past few years. So if you I- um, if I say something and you're not sure what I've done, or if you have any questions, you can either post in Discord, you can send us an email after, or you can try and follow the solutions. Um, and we actually we encourage a lot of the participants to publish their own write-ups. And so if you don't like our write-up, you might be able to um, Google the challenge and actually find a different write-up by somebody else. Um, I don't know if we have anything indexed yet, but um, I've seen a few write-ups published for our challenges before. All right, so in this CTF, we had 6 challenges. Every month, we kind of move around the different categories that we do. So, for example, one month, binary exploitation might be the most difficult challenge. Another month, cryptography might be the most difficult challenges, and so forth. Um, Usually, the first 3 challenges, we estimate what we think the difficulty is, but often the actual point value ends up changing because we thought that maybe like this challenge was easier than this one, but it ended up being the opposite. So it changes. Um, but the first challenge that we had is called Baby Something, and it's a forensics challenge. It goes, how does this song go again? Baby something. Do. Maybe Connor, you can sing it. Um,
Yeah, I don't know how to sing it, but I know what the something is.
and so if you know the song, um, something is shark. If you don't know what it is, you can Google it, but um, I think it's a kid song. Yeah, Baby Shark.
Oh my gosh, it's on repeat. It's like you can get on repeat so much if you've got, like, little niece, that's yeah, or little cousins. Yeah, that's gonna be on in your house 24/7.
Well, and the reason we have this here is because it's a hint that the tool that you need to be using for this is called Wireshark. If you every CTF challenge has a few different parts. There's the challenge title, there's the point value, number of teams that solved it. These two numbers help you kind of figure out what the difficulty of the challenge is. Um, and then we have the challenge description, which is kind of the core of the challenge. Um, Often it might point you in the right direction. It might give you some context about what it is that you're supposed to do. It might tell you explicitly where you need to look for the flag. And then your goal becomes kind of figuring out a way to get there. Um, but pretty much always it's going to give you some kind of resource that you need to look at. And that resource might be a website that you're trying to hack. It might be some kind of hard-coded string. It might be some kind of image. Or in this case, it's a file that you have to download and analyze. And so I'm going to go ahead and download it. And you can see that the file extension is a .pcap. And if you don't know what a .pcap file is, it's well, PCAP stands for packet capture file. 90% of the time, it's usually referring to a network packet capture file. So, for example, if you might have, you know, a, the way computers communicate with each other is through, the TCP/IP protocol, and they send packets, to the client, to the server, and back and forth. And you can use a tool like Wireshark or TCP dump or some other tool to actually intercept those packets and analyze them later. And a PCAP file is just a file that contains the log of all these different packets that have been sent over the network. Um, the reason it's not always a network packet is because you can also take PCAP files of USB traffic, of some other protocols that are not, I guess, technically network packets, but most of the time they're network packets. And in this case, if you open the file, you will see that they are in fact network packets. There are several different tools you can use to analyze these files. The most common one, like I mentioned before, is called Wireshark. And that was the hint from from this song verse. I already have Wireshark pre-installed, so I can just simply open the file and open up in Wireshark. But the way it's going to look like is you'll see a list of all the different packets that have been transferred over the network. You can see the source, the destination, the protocol, the length of the packet, some of the information. You can change this view. This is what Wireshark looks like by default. But there are a few different ways you can go around solving this challenge. We can see right here that there have been a few packets sent from the source to this destination and then back and forth. And they've been using the TCP and HTTP protocols. HTTP runs on top of the TCP protocol, so this makes sense. But the way you can analyze these packets, TCP packets pretty easily, is if you right-click and then follow TCP stream, and then we'll tell you all the information that was sent back and forth. So here we see that the client sent a get request to babyshark.local using this user agent, and then the server replied with the following HTML page that contains, this page with the flag. So this is one way of analyzing kind of this packet. So this challenge is meant to be a very relatively easy introduction into Wireshark, where often if you run a packet capture, you'll see hundreds, or thousands of packets coming every few seconds. In here, we isolated just the single request, so it's a lot easier for you to analyze. Since we know that this is HTTP, you can also click on this HTTP protocol packet and click follow HTTP stream. This will give you the exact same answer. You can also file export objects HTTP, and this will find all the different files that have been downloaded over the network over the HTTP protocol, and I can actually save it. I know that it's an HTML file, so I'm just going to save it as such. It doesn't matter what it's called. But if I open this file in my browser, this is exactly that page that was downloaded. And you can right-click, view page source, and this matches exactly with what we saw in Wireshark.
Wow, I actually didn't know about that feature to pull it out the HTML. You can pull that out and load it up straight up. That's really cool.
Yeah, and it's really useful, especially if you have other files that are loaded on the side. So for example, images or JavaScript files, CSS files. Instead of looking at them like this, you can export all those images and look at them separately. And also, if you're analyzing FTP packets or some other protocols, it's really useful for that as well. So you don't have to manually try and copy out the encoded string and then decoding it. Since this is not using TLS, not using HTTPS, using the HTTP protocol, that means all of the data that's transferred is plain text. So usually, if you try capturing some of the traffic going from your machine, it won't be as easy to analyze these different HTTP packets. But one of the benefits of well, I guess side effects of this is that even if you didn't figure out that this challenge relies on Wireshark, you can simply open this file in a text editor like this. Oh, wrong one. And if you look through the file, you'll see the flag in the file itself, just because the Wireshark PCAP files don't necessarily encode the data in any way, depending on the protocol. And so you can just simply pull it out, or you can use a tool like strings to get to it. Let's see. Yeah, any questions about this one, Connor? Anything you want to add?
Yeah, no, for me, all good. I mean, that's really cool to see that. Like I said, I've pulled out images before, but I never really thought to pull the HTML content out where you can see that. And that could be good if you're doing some sort of other analysis beyond just the PCAP. You can take that further. It's a lot easier than analyzing it from within.
Yep. And let me actually show you what Wireshark looks like. So if I'm not sure if I need to run it as root. Let me try open, no, Control N. Let me just close Wireshark and open it up. So it prompts me for the interface.
Oh, you want to start a new session, right? From the
Yeah.
Yeah.
So you'll have to pick the interface that you're capturing on. I have some virtual machines running Ethernet. This is my home network, so hopefully hopefully nothing
Censored. We'll put little black bars
yeah,
all over the
sensitive started getting captured. But you have to pick the interface, and you can start recording
Yep.
all the packets. Oh well, I guess you can see my IP address. But right now I'm streaming from here, and so that's what I assume this UDP protocol is. Um, and if you see how fast they're recording,
Oh
it's
yeah.
only been a few seconds, and we're already at 25,000 packets. So that's where some of these other tools come in handy, because you can't just right click and follow the stream, because
Yeah.
oftentimes it's going to look like gibberish, and it's also going to be possible to look at. But Wireshark is a really powerful tool. So there's we actually have a handful of Wireshark challenges in this environment. So you can, if you want to learn more about it, you can definitely check it out. And we also have the 87 Cyber Range on-demand labs. I think we have probably like 50 Wireshark challenges in there. And I can get you access if you send me an email. Yeah, and forensics challenges usually fall into kind of three main types. There's network analysis, there's file analysis, and then there's memory analysis. Memory analysis is really hard to do in Flash CTFs, just because if you're taking a snapshot of RAM, often at a minimum that file is usually like half a gigabyte. Um,
Yeah.
Even if you zip it up, often like it's a few hundred megabytes that you have to download. And we're trying to run a competition that only lasts 2 hours. A lot of people don't have good internet. They have to spend half that time just downloading the file. So that's why we
Yeah.
don't have too many memory forensics challenges. Um, but we do provide everyone with Kali virtual machines and like Windows virtual machines during the CTF. So these you can use, and they have really fast internet if you want to. Cool. Well, moving on to the next challenge. This one is reverse engineering, and it's called All About Flags. It's been solved by a good number of people, and it says, I wrote a command line application all about flags. Can you take a look at it for me? There's downloads both for Windows and Linux, but they're functionally the same. Just download the version for whichever OS you prefer. Um, the the flags in the title and the description is a hint. It doesn't necessarily talk about the flags that you're trying to capture as part of the CTF. It talks about flags that you might send to uh, to binary over command line. And so what you have to do in this challenge is figure out how to run this file, and then use a special flag to get the flag from the application. I'm going to show you how you would download it. So, I mean, on Windows, I can just open it up. It'll download it. I can open up command prompt and run the file. I prefer Linux. I have Windows subsystem for Linux running on my machine. So I'm going to open this up. And I'm going to use a tool called wget to download this file onto my machine. If I list the files that I have on my machine, you're going to see it right here that was just downloaded. The way you run binary files on Linux is you put dot slash and you put the file name. This is not going to work just because this file doesn't have execute permissions. So the first thing you have to do is you have to give this file execute permissions. And so if I run ls again, you'll see how I changed this. The first column here is the permissions of the file, and you can see here how the user, the group, and everyone in the system can run this file now. And so if I do dot slash, I can now enter the file, and it's going to run. I guess to backtrack a little bit, this is I keep referring to this as a binary file, but or a binary. Binary has a lot of different meanings in IT and cyber. And in this case, it's referring to an application, an executable application that you can run. And generally, binaries refers to to Linux machines, but and executables for I think is a more common term for Windows machines, Windows operating systems, but they're used interchangeably. So all this file is just a program, and the way you interact with this program is through command line, through the terminal. So I downloaded the file, I ran it, and it gave us an error. It said that we didn't specify any action. We can use the help flag for usage information. So this is where the hint came in. These um, special kind of um, strings that you put after the command that you're trying to, if you're trying to send certain instructions to the file that you're trying to run. Um, you can use these flags. You can use these strings to kind of change the execution of this program, and they're called flags. And so if I run dash help, it's going to tell us that we can use the dash 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 flag to get the flag, or we have some other options as well. And so if I change help to flag, it's going to give you the flag. You can copy this and get the points. For this CTF, to make it easier for people to interact with the application, we actually gave you a Linux terminal that you can run this file directly in. So if you click this button and you spawn the container, it will open up a terminal that already has this file preloaded. So all they have to do is just simply run it and then add the flag to see the answer.
That is so cool. Sorry, I just had to say that's a really, really cool feature.
Yeah, and it's kind of limited in its functionality because we can't run containers on this. We can do all kinds of things on this, but for simple challenges like this, it's a really neat way of like making the challenge just easier to work with. And so because we're trying to make sure you don't spend half your time trying to figure out how to set up your environment. You spend most of your time actually solving the challenge.
Right. Now,
Um,
actually, a question I had about that was it looks like the file was an ELF. Um,
mhm,
I know that's an executable Linux, um,
yep.
I guess file. I don't know if file is a good word for, like you said, kind of, but I don't know if ELFs are. I remember this is gonna sound funny, but the only experience not the only experience, but the first experience I had with an ELF file was hacking PlayStation 2s when I was like 13 years old. So I just
Hmm.
call them ELF files. But
Yep.
yeah, I remember that those files would run in Linux, and that's kind of where I guess the funny part is that's how I discovered what an ELF
Hmm.
was. But I wonder, is that a common? Is there any other kind of other executable files in Linux that are fairly common?
Um, so um, I'm not sure about Linux. I know for Windows, I think you usually see there's P, there's MX files as well, and depending on the system that you have, it might be different. But for example, we also gave you a download for the Windows machine, and this is also an executable file, but it's a P32 plus
Yep.
executable. Um, let me see. There's also yeah. So there's ELF. I mean, there's ELF. There's P. Let me see what else we have. Um, yeah, but like Mac also uses a different system. There's MC that's y- that you occasionally see as well, and there are a few other ones, but ELF files are the most common ones on Linux, and then PE files are generally common on Windows. Um, and similar to the first challenge, so even if you completely ignore, even if you don't want to run the file, um, same as this Wireshark challenge where you can open it up in a text editor and see the flag, you can do the exact same thing with this challenge as well. Um, just because we're trying to keep the challenge relatively easy. We didn't obfuscate the strings, we didn't change anything in it. But if I download the file and I open it up in text editor the same way, um, and I search for MetaCTF, um, you'll be able to find the flag. Um, and this is because when you write a program, in C and C++, and you have some kind of input and output, you often have strings that you print to the to the console to kind of to tell the user what's happening. And unless you obfuscate those strings are usually just simply packed into the binary somewhere in the data section, and then the program just references these during execution and prints them out. Um,
Yep.
and and a really nice tool for this is literally called strings. So if I do this and I search for MetaCTF, we'll be able to find the flag like this.
Very cool.
Yep. Any questions about this one?
Other than what I kind of asked, I'm all good. Yeah, this stuff fascinates me. But yeah, I may have had an unconventional but it looks like we've got somebody in the Discord
Hmm.
saying that ELF failed to run on Mac OS. It's not exactly surprising. Jump to container.
Yeah, Mac Mach.
It's
Oh,
probably the architecture as well,
yeah.
I
So,
would
I think
imagine.
the well, I'm not sure. I'm not sure how to pronounce it. Mac O or Mach O. Um, that's the binary usually for Macs, and yeah, and I think this one was compiled for the x86 architecture, and a lot of the newer Macs use a different architecture.
So I think the
Yeah,
solution is to just buy an older Mac so you can run it. That's my
yeah.
recommendation. Kidding,
Or
I
if
actually
you don't want to buy one, you use this or use one of the virtual machines they provide. And let me actually
Yes,
show you
exactly.
what these virtual machines look like, um, in case you've never seen them before. You would enter the access code right here. I think already, well, this one might have already expired, um, but that will give you access to a VM lab. And in that lab, you can spin up whatever operating system you want out of these ones that are available. It's going to take a few minutes to boot up, um, but after it starts, you'll be able to connect to it over SSH or RDP using the browser. Yeah, and I can come back to this later.
Very cool. Mac says Mac and Mach are both basically fine. It's whatever
Mhm.
you said first. Like that's really I when I was younger, I called it GNU. I said GNU all the time. GNU. I was like nobody, and then I heard somebody say GNU. I think like literally a year ago or something, and I realized I was pronouncing it wrong my entire life. But my entire life, but like since I knew what GNU was.
Yep.
But yeah, it was really it was eye-opening for me, so
So the next challenge we have is called Rainbow Box. It's a cryptography challenge. I guess you can classify this challenge as a steganography challenge. In general, we try to stay away from these, because often the solution can be pretty guessy, and if you don't know what you're doing, you have to kind of just guess a bunch of different things until you find the answer. One of the reasons we decided to go this route for the /CTF is because ChatGPT has gotten extremely good at solving cryptography challenges. So if we give you some kind of vulnerable encryption algorithm or like vulnerable implementation of some kind of algorithm, often you can just paste the challenge into ChatGPT and it's going to tell you what the answer is, or write you a script that will compute, or crack whatever encryption algorithm that we're using. Um, but if we give you an image, ChatGPT isn't as good at analyzing those. But actually for this challenge, you can, I think it will kind of get you halfway there. Um, the way we kind of mitigated this is by giving you a big hint. So let me read the description. It says several planes crashed in the same location, but we only could find one black box. All we found was this weird rainbow image. Can you make anything out? So several planes crashed into one. This is a hint, that you're supposed to be looking at something called bit planes. And if you do a little bit of research into images and planes, um, you will learn about something, um, called bit planes. Um, and essentially, what this means is, let me see if I can find a good page. Um, every image has, usually consists of red, green, and blue pixels. And each of those pixels consists of um, generally eight bits. Depending on the image that you have, it might be it might be more. Um, but for example, a standard RGB value has 255 um, values for each of the colors. And if you convert, let's see, color to binary. Let me see if I can find a good. Yes, for example, if I pick a color like this one, you will see that each of the often you see it represented in hex, but you can also represent in binary. And you'll see that each of these values of red, green, and blue have a different binary value. A very common technique in steganography is to take the very last bit and slightly change it. And often it makes pretty much no difference visually. So for example, if I have this color right here, and I simply increase the last or decrease the last bit by 1, you'll see that these numbers, these colors, well, okay, why did I render this one, not this one? You'll see that these two colors are pretty much identical, even though they're different. And one of the techniques in steganography that's used is taking this least significant bit and changing it slightly to encode data. Bit planes is a way of looking at the least significant bit and some of the other bits. So for example, if we go back to this color picker, I might have closed out of it. You'll have 8 bits for red, 8 bits for green, 8 bits for blue, and you can, if you take each of those bits one at a time, you can the first bit of red, second bit of red, third bit of red, first bit of green, and so forth, and you make a black and white image out of just those bits. You can actually hide several different images in a single file, and those different bits are called, if you're looking at them one at a time, those are called bit planes. There's a really nice tool. Let's see, I think it's called Stag. Let me see if I can find the tool that I'm referring to. It's linked in our blog. But if you do some research, there's a really nice tool called Stag Online that will let you look at these bit planes. And so if I download the file and I save it and I put it into this tool, and I click Browse bit planes, or show the different values, you'll start seeing these black and white images that represent the different letters of the flag. And so if I go through each one of them, you can start seeing the flag character by character. So we have M, we have E, T, A, C, T, F, curly brace, F, L, Y, underscore, and so forth. You can, instead of using this tool, I think there's several other tools that will get you to the same answer. You can write your own script to parse out these different bits. But the point of this challenge was figuring out how to learn about bit planes based on kind of this hint, and figure out the flag hidden in this image. And if you look in the center, you can kind of make out that there's something special about the middle. So this might, for some people who've done this before, this might be a giveaway about what it is, even without the hint. But this is kind of the point of the challenge. Any questions about this one?
That's just fascinating. I've never used that tool before. It reminds me of, there's a guy, I don't know if you heard about this guy, but he started putting files on YouTube with the exact same idea. Um, so the video would be frames and frames and frames,
Hmm.
I think maybe maybe 20 minutes of
Hmm.
that of and it's basically a whole file, like 100 gigabytes of data in a
Yep.
singular YouTube video. And
Hmm.
so it's a very interesting way of storing data for sure. But it works. And so I've never used it I've never done the CTF challenge, but people have been finding very interesting, unique ways to put data within data, right? So
Yeah.
that's one of them, YouTube being your newest file storage. Didn't see that one coming, but it works, I guess, for some people.
Yeah, the usual use case for steganography is data exfiltration. I think that's kind of I don't know how many like real world use cases for it, but that's definitely one of them. Is when you're trying to steal data out of the organization in a way that's not recognizable,
Yep.
hiding data and images. Um, I mean, I think nowadays, if you see somebody exfiltrating a bunch of images like this, that hopefully they'll get
Yep.
flagged. But there are use cases when that might be a way of stealing data without triggering
I'd
alerts.
imagine through memes would be a good because then it would just go through a data stream like, oh, he's just sharing memes. That's what he. Oh my goodness, wait a second, But yeah,
I,
storing files as a storing videos as file as a binary for file that is very interesting. When I watched the guy, he's like, yeah, I've
yeah,
uploaded so much data through YouTube, just every frame of it being a different piece of the file, um,
you
which
know,
was very very interesting at least to see.
I've seen a
Never
similar
used that as
concept,
storage before, but
but instead of kind of using this method, you just have a video with a bunch of frames of QR codes, and so you just have you know 10,000 QR codes just flashing with the different data.
yep, and
Um,
it just reads it. Yeah, it's very interesting.
all right, so the next challenge is a reconnaissance challenge or OSINT. Usually those two, depending on the competition, we call them different things, um, but generally they refer to the same thing. And so in this challenge, it's called On the Grid. It says, I was hanging out on the Grand Beach when I found a message in a bottle. It doesn't say very much though. Can you help me figure out where it came from? And here's the transcript. The answer to this challenge is the name of the location the message was most likely written at. So looking at context clues, looking at the text that's written, and looking at what it's asking us to find, um, we can probably infer that these four sets of characters right here are referencing some kind of location. Um, and so pretty much the entire challenge becomes trying to figure out what kind of coordinate system or what kind of geolocation system is being used to figure out kind of uh, to encode the location of this of where this was written. And so um, the way I approach this challenge is just by literally Googling. Um, the way I solved it is I didn't know kind of what to start. So I wanted to find kind of a list of all the different types of coordinate systems. I knew there was another one. It's called What Three Words. I don't know if you ever heard of it before, but it's a way to encode location similarly and just using 3 words. So for example, if I'm trying to find a coordinates for this location, you can just use these 3 words to reference it. Um, the reason I use that is I want to find the Wikipedia page to see what it's called, and it's called a geocode system. And so um, I next kind of went and just looked up a list of geocode systems, and I found a few different links, but I mean the Wikipedia one was probably the most most useful. Let me see if there's. I think this one has the might have the answer as well. But the next thing you can do is kind of go through these different geocode systems and just kind of research them. You can do it one by one. You can try to look at um, some of the aspects of it to kind of narrow down. And if you see, if you see examples, um, none of these look like what we're looking for. Um, if you keep looking, eventually you'll find MGRS, which is the very last one on this um, Wikipedia page, and it's called Military Grid Reference System. And you can see that this that the coordinates in here in this example look very much like the ones that we have listed in the challenge description. So if we compare these, you can see there's some kind of 2 characters, so 2 characters, and then 2 numbers. Um, so this looks like what we're looking for. If I type this into Google, maybe I can find some kind of converter like this one. I'm going to paste the string in, put it right here, calculate. I'm going to look at the satellite of Google, and it's going to tell us on the map that the coordinates reference this island in Alaska. Let's see, is it Alaska? Yeah, it's Alaska. And so if you put in the name of this island as the flag, that's going to give you the points. There are a few different ways of figuring out this answer as well. I think our solution on our blog was able to use kind of the Google Gemini, um, suggestion. Personally, I don't really like those because often, in my experience, it gives you wrong information. But I think in this answer, in this case, putting in something like coordinate system that uses 2 characters, 2 characters, 3 digits, 3 digits, that would tell you it's a military grid reference system. So you could have used an approach like this to try and find it as well.
That's cool. I've never really seen the MGRS before, so that's very all new to me. So that's cool to see.
Mm-hmm. Yeah, and creating OSINT challenges has also gotten a lot more difficult because of ChatGPT and other similar tools, because they're every month the level of difficulty that in our Flash CTF that these tools can solve keeps going higher and higher, and so we're trying to figure out ways of kind of making challenges that are harder for tools like ChatGPT to find. And one of the ways we do that is by images, but by having some files that it can't analyze, or by doing things that you have to feed more information into ChatGPT in order for it to be able to figure out what it is that you're asking it. And so this one wasn't quite as easy. So we have a few more minutes. I can talk about the web exploitation challenge in the CTF as well. So this one was one of the more difficult challenges in the CTF. I think if you compare it to our previous Flash CTFs, it's not the most difficult, but you can see that we had a good number of teams that were able to solve it. It's called Super Quick Logic Invitational. It talks about a trivia game that's pretty fun, but it has a challenge that's impossible, and it's called "What is the flag for the CTF challenge?" And it's asking you to try it. So I'm going to spawn the container, open it up, and see the game that we have right here. So this is an example of a black box CTF black box web challenge, as opposed to white box, where we give you the source code. We don't give you the source code for this one, so you have to kind of look at the application live and analyze that dynamically to see if you can find a vulnerability. So the first thing I'll do is I'll just click inspect, open up the network tab, and see what kinds of requests are being sent back and forth. We can look at the page source and see that it's using plain HTML. It doesn't seem like there's anything interesting, but there is a game endpoint. So we can let's try playing this game and see what we can do. So I'm going to restart, click start game. It tells us we have 30 seconds. It tells us our score, and it asks us to answer this question. So I guess first let's just try putting in a random answer and see what happens. So we put in a random answer. It sent a request to submit with our answer, and it told us that it was incorrect, and our current score is 0. Let me try this real quick. 18. Oh, I ran out of time, but I think the correct answer was 18. Let's try this again and actually solve the challenge correctly. What is the remainder of this divided by 37? It is 5. Correct? Let's try another question. 34.
College professors are not going to be happy at you, Roman.
Well, I mean, here, I'll use Python for this. Well, this one I can't just Google. Left together will feeds code. Let's just guess. 3, 4, 5, 6, 7. If you have 4 switches that can be on or off, how many different combinations can you create? This is just 16, right?
It'd be 16.
Yeah.
Yep.
Yep. Okay. Well, there are 200 questions, and so I can keep playing the game, and I can keep trying to answer the questions. We know that the last question is going to be pretty difficult. It says, like, what is the flag for the CTF challenge? And I'm just going to let the game time out, and we can see what happens when the game times out, and you don't have the right answer. Let's see. Yeah, so what happens is it sends you to this game end page, and it lists all of the different all the different questions that you were presented with during the game, and it tells you what the correct answer was.
Gotcha.
Solving the last question, even if we get to it, is going to be impossible, because it's going to ask us about what is the flag for the CTF challenge, and in order to answer it correctly, we're going to have to know the flag before we can answer it. And so without exploiting this application, there's no way for us to get this final answer and get the flag. So we have to start trying. We have to try and find some kind of vulnerability. And the way I'm going to do that is I'm going to start by simply just putting in random special characters, and see what happens. I click submit answer. The request fails. It tells us there's an error, and it tells us there's a SQL error near this location. So it looks like this application is vulnerable to SQL injection, and I can show it to you right here.
Yep.
It selects data from problems where it selects data from problems where question ID equals 102, or whatever the question is that we're trying to solve, and it checks to make sure that the answer that we entered is correct. In this case, we entered a single quote, which broke the SQL query, and through this error. We can use a standard. Well, here, let's time it out. I have the database. So as a participant, you won't have access to this, but this is the database of the questions that are used in the challenge, and I can try this again, and I'll show you what the query looks like directly when you run it against the database. So if we know that this is the query, this ID number is entered dynamically, and the answer is generated by the application, and this answer that we enter right here is something that the user has control over. So for example, if I enter some kind of random answer and I run the query, it's going to find no rows in the database, which means that my answer was wrong. If I look at the questions right here, I'll see that 79, the correct answer is 90. So if, for example, I solved the challenge and entered 90, I would know that the query would find a single row, and it would tell us that the answer is 90, and we got and because we found a row that matches the challenge ID and the answer, it means we got it right. Since we have control over this field right here, I can modify the query that is being executed using SQL injection. One of the most common payloads that you might see online looks like this. And the reason it works is because if I take this as my input and I paste it right here, you can see that this becomes a valid SQL query. And what happens is it checks to see if ID equals this, and answer equals nothing, or 1 equals 1, which always returns true.
Yep, which is always true. So it just, you don't even need to know the answer anymore.
Yep. And so in this case, if we run it, it is going to find, all the it's going to return all the rows, and the application is going to think that our answer is correct. So if we try this in the application, play again, I can answer every single question simply using this query, because regardless of what the answer is, by modifying the query execution, it's going to find a match, and it's going to think that I answered the question correctly. So even though this works, this is not going to get you the answer, because if you, I'll let the game time out. The only way for you to figure out what the flag is to have it printed as part of the answer on the final page. And if you just keep entering this, it's gonna, I think it's just gonna always print the first value that gets generated as the answer, as the correct answer. And so it's not gonna give us the flag. So we have to use something different to exfiltrate it. So once the time's out, you can see that, the answer is the same for all the questions. And this is simply because that was the first row
Yeah, I
of
see.
the database.
Yep.
And the way we can bypass that is we can use instead of this plain kind of exploit, we can use something a little bit more interesting. We can close the query, and then we can use something called union to select. Let's just select 3 random numbers, or 4, from the database. We're going to finish the query, and we're going to comment out the rest just to make sure that this quote doesn't cause us any issues. So if I now enter this as our payload, it's going to select. Well, it's going to fail because we have a different number of rows. But if I change this to 4 numbers, it's going to return this as the values from the database. And through trial and error, you don't know how many values this application returns. But if you use a query like this a few times, and you just play around with a different number of characters, you'll soon figure out that it has there are 4 columns that are being returned as part of the database. If we let a time out, we'll see that the answer was number 3, was this value. And so this means that if we're able to replace this value with something interesting that we're looking for, we can start exfiltrating data out of the database. The application uses SQLite, and we can actually exfiltrate data from this database by selecting. So every single SQLite database has a table called SQLite master that contains information about the database. And if I look it up, let me just run another query and see. And this is something you can research. This is public information. It's not something you have to hack and exploit out of our database. There's the SQL field that contains information about the table in this database. And so if I modify this query to instead select SQL, this will return in the 3rd place. It will return the structure of the database. So if I copy this as my payload, I should be able to exfiltrate the data this way. Yeah, and you can see 3 was the answer. So we entered 1, 2, 3. And if I enter this, it's going to tell us it's correct. And once the time's out, oh wait, I have to let a time out. It's going to tell us what this database looks like. And if I just copy this out to show you, you'll see that it says create table problems, ID, question, answer, difficulty. And the entire reason we did this was to figure out what the name of this field is, because it's not something that's revealed in the application. So using answer, so the column answer is the one that has the correct answer. So in order to get the flag, all we have to do is replace this with answer, and we're going to select from the problems table where ID equals 201. The reason I'm entering 201 is because, well, I already know that the last question that has the flag is going to be stored at the ID 201. This is something that you can also figure out by just playing the game and
Right.
seeing that the last answer is 201. But if you don't know, that's what it's going to be like. But if I enter this as the answer, yeah, and you can see right here, this is the query that tells us what the name of this field is, and we already know its problem is just because we saw it elsewhere. But if I enter this payload and I let it expire, it's going to pull. Well, I guess let me just try to make sure my query ran. Yeah, it's going to pull the answer from the database and print it out. And I saw there were some comments on
Yep.
restring. Let me see.
Yeah, we got some comments on it. From Siri
Yep.
Serial. I swear I saw another I in there.
Oh, okay. You're right. So this entire step with SQLite master was kind of pointless because you're right. It isn't. Yeah, you're right. It is a part of the query. So I guess you can forget about all the SQLite structure part um, and just solve it this way. All right. So yeah, that kind of that covers this challenge. If you want to try it yourself, you can go to the Flash CTF or you can go to our practice environment. It's going to be in there. We also have we launched a new version of the anti-7 cyber range called MetaCTF on Demand Labs. And if you look, this environment has pretty much all the questions from from anti-7 cyber range, plus all of the practice questions in it as well. And I mentioned it earlier, but if you send me an email, I can give you access to the platform, or there's a free trial that you can use. But this will have all those questions in there as well. I don't think we have time to go over the last question. It's in the binary exploitation category. It's kind of a mix of CSV injection and binary exploitation, but you can look at the write-up on our blog. It's a relatively straightforward challenge once you know what it does. But it's pretty interesting the way the vulnerability works. Yeah. Any questions about this challenge or anything else about the Flash CTF? Thanks, Connor, for hosting me.
Yeah, no problem. Thank you for running through them. It was really cool to see some of this stuff. Yeah, shame we couldn't go through the other one, but like I said, we've got the blog because binary exploitation that looked pretty fun to me. I just saw it for only a split second when you were scrolling through it, but yeah, no problem at all. And thanks guys in the chat. I see we were kind of talking a bit there, getting a little bit of extra context for some stuff, which is always great. But yeah, it was fun running this. I've never run it before, so I don't really know the general kind of structure. But yeah, like definitely agreed. It's always nice to see walkthroughs. They always help out. Yes, join the CTF. That'll be fun. I used to be intimidated by them too, and then I just started doing them, and I realized they were more fun than intimidating. Um, Especially Meta CTFs ones, I think. Oh, Roman, you look like you're muted.
Yeah, and especially the Flash CTFs, you saw that like at least the first 2 or 3 challenges were relatively reasonable for somebody with very little experience to solve. And so we do try to have some easy challenges to make sure that everyone who participates is able to solve at least one challenge. And we try to make the requirements for you to participate as low as we can. So we give you a virtual machine. Oh, so I think that the virtual machine that I launched might actually be ready now. So let me see. VM lab. Yeah. So during the Flash CTF, you're given free credits to use these virtual machines, and all you do is just you connect to these over RDP or SSH, and you can interact with them as if you were on a machine or using any other virtual machine. Do allow clipboard sharing. This will make it easy for you to copy and paste things out of the virtual machine. So for example, if I do this, a lot of people complain that they can't copy and paste things out of these virtual machines, but if you enable clipboard sharing, you'll be able to. And you can also click Control Shift Alt to kind of see the clipboard as well. But yeah, if for example you feel anxious about downloading any of the files that we have on our platform, or you don't feel comfortable running tools, you can just use these virtual machines to do everything from there. We have Ubuntu and we have Windows. In case there are some tools that you can't run on a Linux machine, you can use the Windows environment for this as well. Cool. Yeah. So our next one is going to be on September 18th, 5 p.m. Eastern. It's a Thursday. And then we're going to have another CTF before then on Saturday, September 13th, called Road to Cyber Bay, where we're going to pay for at least 5 teams to travel to the conference in Tampa in October. Yeah,
Yeah.
I think that covers it.
Awesome. That's great to hear. I wonder if anybody here in this chat, are you guys planning on being there? Hopefully you can maybe fly out. That would be really, really cool. I myself, I don't believe I'll be making it out there, but I'm sure good number of us from Black Hills Anti-Cyber Training MetaCTF, we're going to be there. So
Yeah.
that'll always be a fun time.
Yep. Well, yeah. Thanks again. Once again, don't hesitate to post questions on Discord. Tag me because I don't usually check that. So if you want to get my attention, tag me. I'm just my name on Discord. Or you can email me at rome@mnst.com. You can connect with me on LinkedIn. Email support@mnst.com. We're pretty approachable.
Yeah. Or you can tag me to tag him. No, I'm just kidding. That would be pointless. But yeah. Thanks guys for interacting with us. And unless it's it, I guess we'll see you guys around.
Yeah. See you.